ઘરે ઓલું ટેલિસ્કોપ ફેરવતા આવડે પણ અહીંયા કેમેરા ફેરવતા નથી આવડતું. ઓકે, so we understood how liquids wet or surface depending on which kind of forces, right? Okay, now we're going over to the next thing related to contact angle, right? And that is capillary action or capillary rise. Capillary no spelling photo pade to મને દેખાડો. Is this the correct spelling of capillary?
Yes.
Are you sure?
Yes.
બાયોલોજી માં આવે. હા એ તો બરાબર એટલે જ તમને મેથ્સ વાળાને હું આવડો because I know they wouldn't be remembering it. So capillary action. First of all, you need to understand what is capillary. I'm sure you do know that. What's capillary?
Small vessel.
A thin vessel or a thin tube. Correct? Alright? Not like a pipe. A very narrow one. So that's the key thing here. It should be thin or narrow. Right? The diameter should be less. Only then you are going to see this effectively. Now, what is capillary action? It is that if you would, let's say, take some fluid in the vessel and now you dip a very thin capillary, that is a small or narrow diameter tube, then it has been noted that either the liquid in the capillary will rise, that is અહીંયા ઊંચું રહે એમને મજા without doing anything, not like the barometer, no such stuff, ખાલી આપ મૂકવાની જ rise. And in some other cases, in some liquids or with some tube, what happens is that it goes down or to empty. Did you understand what I have shown? That is, the liquid is here and the liquid is here. So in one case it will rise and in another case it will fall. Understood what I said? So this is what is called capillary action. Right? Capillary action means when you dip a capillary inside a vessel, the liquid level inside the capillary will either rise or it will fall. It could remain same also. So basically something happens between the capillary and the fluid that either causes it to rise or fall. Right? Now how much it rises, how much it falls, that's what we are going to find out. Right? And whether it rises or falls has a very simple and yet important relation with contact angle. That's what we have studied the last time. Right? Whether it rises or falls has a relation with contact angle. So first of all, let's write that observation. It is that if contact angle of the liquid with the tube is acute, the liquid rises in the capillary. And the other one, opposite of this. This is number one. Number two, if contact angle of liquid with the tube is obtuse, the liquid falls in the capillary. Did you understand these two sentences? Draw diagrams next to them. Okay, or at least below them. And there is one third sentence also which is actually the easiest one. One is what acute. Acute means angle less than 90. You look theta less than 90 degrees. Theta for contact angle or theta C if you want to write it that way. Right? Here we have theta C greater than 90. That is obtuse. For obtuse, the liquid falls in the cup. And last one, equal to 90. What happens over there? What do you think? Yes. Yes, it will remain at the same level. less than 90 it will go up, greater than 90 it will go down, but equal to 90 it will not change. I hope you'll be able to write it on your own.
Yes.
If the contact angle of liquid with the tube is 90 degree, right angle or 90 degree, yeah, then nothing happens. That is, liquid level neither rises nor falls. Okay, done with the three sentences. That these three cases are definitely worth remembering, mind you. Okay. Now, first I'll give you a qualitative reason why should this happen. Then we'll analyze the maths. See, suppose this is, let's say, glass. Let's understand it with an example. Glass, and this is water. So yesterday I did tell you that glass can be wetted by water. Do you remember that?
Yes.
Right? Okay, so that means the contact angle is
Obtuse.
acute. Okay, that means the contact angle is acute. Acute જ છે, obtuse ના આવે, acute જ આવે. Okay, so why was that? Why was that? When is contact angle acute, or when does a liquid wet a surface? When adhesive forces are stronger than cohesive forces, or overall they are more, right? So what happens is as follows. Listen to this carefully. પહેલા એકદમ physics વાળું reason, પછી maths આવે. This is glass. When water is at this level, what happens is that the glass molecules over here will attract the water and pull it up. See the difference. In one case, suppose a surface, a vertical surface of glass, right? In this case, this contact angle is 90, which is wrong. For water, the contact angle is not 90; it is acute. So what's going to happen is that the glass molecules over here will pull the water molecules over here up. It is arm thing. You understand what I'm saying? Have you noted such shape of water in a test tube or something ever?
Yes.
એને meniscus કહેવાય, ખબર હોય આવો shape થઈ જાય. Never mind, I'll show it. So don't worry. Again, I'll repeat the reason. It's that the glass molecules of the tube, they're going to attract the water up. And then ઉપર ખેંચી લેશે. So this here will rise. Not only that, it will rise of course, and shape will also not remain flat. The shape will become like this. Understood? Right? The shape will become like this. On the other hand, if cohesive forces are more, the opposite is going to happen. Right? Opposite is going to happen. That is, the fluid will not like to come in contact with the tube. With the tube. Whatever that tube is. Again, try to recall those droplet shapes. Let's say,
Yes.
why are they like this? Here, this liquid tries to come in contact with the surface. And you imagine the surface. I hope you understand why it will rise. Because it wants to touch that surface more. On the other hand, over here,
Don't like.
it doesn't like to come in contact with that. Is that clear?
Yes.
So, આમાં શું થાય? એવા કેસમાં ભાગી જશે. It will decrease. The level will decrease as much as it can. Any limit, of course, right? Because I hope you realize if this level goes down, આ બાજુથી pressure વધુ હોય, then પાછું માટે જા. There will be some equilibrium. Make sense, everyone? કેમ આ સીધું આમ બધું હોય કેમ ન જાય? અહીંયા આવું જ નથી. Problem, pressure. The pressure over here will push the fluid back into the. એવી રીતે અહીંયા કેમ છે કે ઉપરથી ઉડી ન જાય? Same problem, pressure. The higher it goes, the more pressure will be, so it will bring it down. Clear or not clear? So there is some equilibrium. Yes, Vedant? No time. No time. That's what we are going to derive. Okay. So that's what is going on here, right? The fluid will rise and the fluid will 4, depending on whether it likes to come in contact with the surface or it does not. Yes, here. Can you please say your question again, louder? Meniscus will, in this case, this one, right? Yes. Okay, yeah, I forgot to mention that. You are right. There will be a shape over there also, but it will be exact opposite of this, right? So here, what is going on is that glass is attracting water, so it pulls it up and see it makes the contact angle acute. Yes or no?
Yes.
On the other hand, suppose you dip glass tube in mercury, it's going to push it down, and there the contact angle will be opposite. So, I'm out of space here, so I'm going to draw two such diagrams. One is this for acute contact angle, and now I'm erasing this one, right? So this is for obtuse contact angle. આવું થઈ જાય બાર ઉપર અને અહીંયા નીચે. Does that make sense to you? Air, suppose mercury, glass tube. It will become like this. So that what's the contact angle? Have a look. I'm drawing here. So you have to take angle between this and this. Remember, inside the liquid, this is mercury. So this is obtuse contact angle. Alright? Clear or not clear? Okay. So we have these three cases, right? Along with those three cases, let's write three similar points. Okay, come on. Number one. Three similar points. Number one, again. If contact angle of liquid with tube is acute, it is also same thing. The liquid forms a meniscus. The liquid forms a meniscus concave upwards. Meniscus means that shape, the upper one. Okay. તમારે બાયોલોજીમાં ક્યાંય meniscus related okay. The shape of eye lens is a meniscus. Okay. So what is the first point telling you? It's describing this diagram. Okay, any બાજુમાં one love with a love. See, we are going to have 6 sentences now, right? And all of them, they are important. So first one, if the contact angle is acute, then the liquid forms a meniscus that is concave upwards. What is the meaning of this term? This is a mathematical term, mind you. In physics, concave upwards. What does that mean? Concave કોને કહેવાય એ સમજાવી દઉં છું for the last time 12th માં repeat કરીશ નહીં. નો આવડે તો કઈ વાંધો. Concave means to open. The simplest meaning of the word concave is to open, right? And conversely, convex means to close or to be closed. Okay. So have a look at this. This shape, our shape is koi baju open hai. Where does it open?
Upside.
What that?
Yes.
Right? Concave convex mirror out to 10th month.
Yes.
Give the 12th may out. Right? 75% of that chapter is safe. The 10th month to reach 12th. Okay. The second sentence, if contact angle of liquid with tube is obtuse, then what happens? The liquid forms a meniscus. Again, what is meniscus? That shape. Liquid forms a meniscus. That is what?
Convex downwards.
Concave downward. Okay, that is concave downward. What is meaning of concave downward? This one. Each a broad side, correct? It opens downward. Fine. You can also write it as convex upward. પણ એવું બે બે વસ્તુ ન કરતા બે માંથી તમે મને ખબર છે બે માંથી ખોટું જ સિલેક્ટ કરીને આન્સર લખો. So remember only one. All right, this is concave upwards. This is concave downward. Again, if you remember these two words, then there is absolutely no confusion whatsoever. ગોખવાની try ન કરતા. So that's it. What about 90 degree?
Horizontal.
Meniscus is flat. Look now. Meniscus is flat. So now we have talked about 6 sentences and 6 diagrams. All right. 1. If contact angle is acute, the bay result time. What's that? One is that the liquid will rise in the tube. The second is that the meniscus is concave upward. Second is if contact angle is obtuse, then liquid will fall in the tube and meniscus is like this. That is concave downward. Right? Third one, contact angle 90. Liquid will not rise, not fall. Remains at the same level inside and outside. And the meniscus is also flat. Clear? Okay. Now, that's for the qualitative part. Now, mathematics. So let's take a simple case right now where the angle is acute, right? Okay, let's take a simple case where the angle is acute. આમાં બહુ બધા diagram draw કરવા પડે એવું મને યાદ આવે છે. Let's say this tube has radius smaller. Okay, tube no radius capillary. This is the radius of the capillary, smaller. Right? And suppose outside the fluid is still here. Suppose outside the fluid is still this level only. But here, of course, there is fluid because it has risen. Did you understand what I am saying? Or two today? Right? I'm already proud of my diagram. Now, good so far? Is it clear what I have drawn? Where is contact angle? Here. Theta. Right? That theta is contact. Now, let's say that this shape you are seeing, can you imagine that it's actually a part of a big sphere?
Yes.
Alright. Okay or not okay?
Yes.
Can you imagine it's a part of big sphere? Now this sphere, let's say its radius is r. આ ડાયાગ્રામ બહુ કોમ્પ્લિકેટેડ થઈ જાય, જરૂર પડે તો બીજો ડ્રો કરજો. Did you understand what is capital R? Capital R,
Radius of sphere.
radius of that sphere. Again, I advise you, if you're finding that it becomes untidy and you cannot see things properly, draw anew. ખાલી આટલું જ draw કરો, આ બધું ન કરો, સમજાઈ જશે તો. Now, we are going to do some geometry, trigonometry over there, right? And we are going to take 2 points. Let's say one point A over here, or just below this actually, right? One over here B, one over here C, and then D later. Just above this. You understood where is A and D?
Yes.
What is between A and D? That surface. Clear? Understood? Where is A and where is D? D is slightly above the surface and A is slightly below that surface. B and C are at
Same level.
same level. ખબર તો પડી ગઈ હશે કેમ લીધા same level? Why so? Pressure here and here is equal. બધું આમ તૈયારી થઈ ગઈ. Right? Okay. Now we are going to first of all find a relation between this small r and this capital. Okay. So, do you agree that if I make a right angle triangle like this, here I am more to draw. This is R, this is capital R. Yes or no?
Yes.
Do you agree with this? R radius, I radius is like. Okay. Now, here we have angle theta. Look at this carefully. This is the most crucial one. Here confusion વધારે લોકોને. This angle is theta. Right? Which angle is theta? Here there is a vertical, which is the glass tube or the surface of solid. A contact angle. બરાબર?
Yes.
બરાબર draw કર્યું ને?
Yes.
I hope I am not making mistake. This angle is 90.
Yes.
So this angle is 90 degrees minus theta. Now once again, this is the radius, a radius of a sphere, and this is a tangent. Radius and tangent are always perpendicular. Very good. So આ angle પાછું 90. અહીંયા 90 માં theta આટલું. So remaining should be theta. Yes or no?
Yes.
Yes or no? How many of you understood that this angle here, આ angle દેખાય તે theta? Okay, put your hand up. Would anyone like me to repeat? Okay. Fine. So we'll start from scratch. Okay. Change of color. This angle is theta, correct? It will come there between radius, and this tangent. There is 90. So here 90. Okay. There is one more 90 where between horizontal and vertical. So there is one more 90. Now if this is theta, the remaining of 90 should be 90 minus theta. Yes or no?
Yes.
Got to 90 minus theta there. Follow this carefully. Watch this right angle. Now vertical, horizontal, let me go. Theta तो यहाँ नहीं बनती. Clear? In doubt with this step? Okay. Now look at this right angle. Now बीजू right angle देखा है?
Yes.
If one angle is 90 minus theta in a right angle, the remaining should be theta. How do you think that? Now we are going to use this right angle triangle once again. We are going to use this right angle triangle, and I am going to write a very simple relation from the diagram or from the figure. R equal to capital R cos theta. Yes or no? એની ઉપરના સ્ટેપ તમારે જાતે વિચારવાનું. Look at this right angle triangle. Cos theta. What is cos theta? Adjacent upon hypotenuse. અહીંયાથી ચાલુ કરો. Cos theta equal to small r upon capital R. તો આવે ને બધી? Yes or no?
Yes.
Okay. So we get small r equal to capital R cos theta. Okay, leave this aside. We'll use it. Now, conversely, you can also write capital R equal to small r by cos theta. Fine. I don't think anyone has any problem with that. Call this equation 1. We'll use it later. Now, let's go to the next thing. The Pascal's and all that. Okay, fluid. Fluid now. Now, PD minus PA is equal to 2S by R.
Yes.
Nanti how you?
P inside by the
Exactly. This part you can think of it as if this is a air bubble actually.
Yes.
Right? So this is air bubble in water. So here there is pressure P inside, that is PD. Here there is pressure
outside.
P is outside that bubble, and that is equal to 2S. Fine. So capital R ની value શું છે?
R by cos theta.
2S upon R, and here you get cos theta. Clear? Now, what do you think is speed? Our point क्या है? Air में है. What about? Okay, fine. That's clear or not clear?
Yes.
So we should have we should have that PD is equal to PC. Yes or no?
Yes.
Yes or no?
Yes.
Sure. Why? What's above C?
Yes.
What's above D? Was air. Atmospheric pressure in both cases. So we have PC minus PA is equal to 2s by cos theta. What's the reason? PC is equal to PD equal to atmospheric pressure. Right? One more step to go. PC is equal to clear. PC equal to PB. Is it okay or not okay? So what? PB minus PA is equal to 2s cos theta by half. Right? Because now why is PC equal to PB? Same level. PC equal to PB. Same level, same fluid. Don't forget that. With fluid, whatever it is, water is a water. Understood? Now, next step. B and A are in the same fluid, but they are different level, different depth. So variation of pressure with them. Let's say that this height till here. So what do we have? PB minus PA. What is it? PB minus PA. This is it. What is PB minus PA? नहीं आपको लगवा, don't worry. I was expecting everyone would know it now. હવે તો ઊંઘમાં આવડતું હશે, નહીં આવડતું હોય? Major. Yes, that is rho GS. Okay, so we got formula of H. How much is it? 2s cos theta upon r rho g or rho gr. This is the formula of capillary rise or capillary action. આ ડેરિવેશન છે, શું ડિરાઈવ કરવાનું, આ ડાયાગ્રામ ડ્રો કરી. ઓકે, so what have we derived? We have derived that if you put, listen to this, we have derived that if you put some fluid and then you dip a capillary tube, then the level inside the tube will increase by a height h. E height h કેટલી હશે? આટલી. That's what we have done. Is that clear? That height h will be 2s cos theta upon r rho g. Okay, so time to write terms. આની terms ઘણી બધી છે. What is H?
Capillary rise.
H.
Capillary rise. Height of the fluid which rises inside the capillary.
All right. Height by which fluid rises in capillary. H is height by which fluid rises in capillary. Shall I write it on the board? Height by which fluid rises in capillary. બાકીની ટર્મ્સમાં બહુ વાંધો આવે એવું નથી. S for theta for contact angle. Angle of contact or contact angle. તમને theta c લખવું હોય તમારે તો theta c લખો. Okay, I don't mind. You can write theta c if you want. Again, theta is contact angle. R for
Radius of capillary.
which R is that? What is that? Yes, these are radius of the capillary tube. એટલે જો તમને કહું કે diagram draw કરો. આ diagram બાજુમાં draw કર્યો તો terms માં mistake જ ન થાય. I hope you are seeing that. The rho for density of fluid, G, you know what. Yes, Vedant, you are still in doubt whether to ask the doubt or not? Okay, so this is it. Now, there is one interesting thing that I must mention. Here we have, while we derive this, we consider that it rises. The same derivation, the same formula is true even if the liquid falls. But what happens over there is, worth exploring, because there's a bit of math here and you probably don't know it, right? I'm not sure, you might be knowing it. At least I don't think I've told you. Can I erase this part here? So it is about angles. It is about angles and the value of cos. अच्छा मैं लिखा है भैया. Do you remember that if theta is greater than 90 degree, value of cos theta is negative?
Yes.
Table लिखा है भैया से 0 to 90 you have studied in 10. Then I made you write 120, 135, 150 and 180. Can you like it? So hopefully if you remember the values you realize that cos theta will be negative. So what would happen? If cos theta is negative, this whole thing becomes negative. That is h instead of rising
Fall.
बराबर है? वही वाला point याद करो. The point was that if contact angle is greater than 90, if contact angle is greater than 90, that is obvious. Then what will happen? The liquid will. Are you doing a math? Clear? Okay. So that's it about this problem. Right? That one. Given everything else is same. Given everything else is same. Do you see that H is inversely proportional to R? What I'm saying? If everything else is same, that is, you are taking the same fluid, the same tube, but of different radius. Same material, tube, but of different radius. Then H is inversely proportional to R. What would that mean? The thinner the tube, the more the fluid will rise. જેટલી પાતળી ટ્યુબ લો ને એટલું ઉપર આવે. That is why you don't see capillary action when you fill water in a glass to drink water. કારણ કે glass એટલો મોટો. You understand what I'm saying? એનો ખબર પડી. Right? Because glass has big diameter and big radius, isn't it? કે તમે આવી નાની આટલું પાતળું હોય એમાંથી પીઓ? No. Right? So H is inversely proportional to R. Thinner the tube, the more the level will rise. Yes, Vedant, your question.
Sorry, PC is equals to PA.
Sorry, if
PC is equals to PA.
PC is equal to PA, yes.
Then PC minus PA is equals to 0.
Of course.
So then 2s plus beta upon R will also be 0.
If okay, wait a minute. What did I say? What did you say? PC equal to?
PA.
No, that's wrong. PC equal to PD.
Sorry. PC is equals to PA because atmosphere. Same as what you said.
क्या ही છે ને PD equal to PA લખ્યું જ નથી.
Sir, પણ બે જગ્યાએ atmospheric pressure જ apply થાય.
બે જગ્યાએ એટલે કઈ જગ્યાએ?
PA at point A and at point C.
At point A and at point C. But there is a big difference. That shape. ಈ shape છે ને એના કારણે આ સ્ટેપ આવ્યો. એટલે suppose the shape was flat. આવું હોત તો શું થાય? Then this radius R would be infinite. Do you know this? Flat things have infinite radius. I don't know whether you are aware. નાનું circle, small radius. જો આમ મોટું કરતા જાવ એટલે almost flat થઈ જવું. Correct or not? So if this is flat, then you will have capital R equal to infinite. સમજાણું તો અહીંયા અમારે લખવાનું હોય 2s by capital R. તો એના બદલે હું લખીશ 2s by infinite. Something by infinite is 0. So PC will be equal to P. So what you are saying is only true if this is flat. Otherwise PC will not be equal to P. PC will be equal to PD. But PC will not be equal to P. Understood? Can't give me much concept. Okay? Yes? Resha, your question? Okay. Anyone else? Any questions? Right. One more formula to remember. Actually, fluid mechanics is something which has lots of concepts. So it's considered as one of the tougher chapters. કારણ કે એટલું બધું અલગ હોય તો બધું યાદ રહેવું જોઈએ ને. Laws of motion માં કેટલું આવતું હતું? 3 laws અને બહુ તો impulse. એટલામાં જ રમવાનું હોય, પણ એના સમ્સ વધારે અઘરા હોય. આના સમ્સ ઈઝી હોય, રાઈટ? બીકોઝ ધીસ ઇઝ ફોર્મ્યુલા બેઝ, ધેટ ઇઝ ઓનલી લોજિક બેઝ. ત્રણેય લો ગોખીને બેઠા હોય તો એ એકઈ સમ આવડે નહીં, એવું થાય ને? ઓકે, ફાઇન. લેટ્સ સોલ્વ ક્વેશ્ચન. વન કેમિસ્ટ્રી નહીં, ફિઝિક્સની બુક હોવી જોઈએ ને, કેમિસ્ટ્રી શું કહો? There is one topic given in the book which I am not going to discuss. It is for you to do on your own. That is soap and detergent. एक लाइन में खाली कही दो. Listen to this here. What soaps and detergents do? They decrease surface tension. Soaps and detergents decrease surface tension. એટલે શું થાય ખબર છે? Suppose this is fabric. Fabric means cloth. તેની અંદર આ નાના હોલ તો હોય જ. I'm sure you understand what I'm saying, right? So let's say there is something stuck over here, dirt, oil, whatever, food, right? And now if you will try to wash it with water only, plain water, then because of surface tension, what will happen is that water will not be able to penetrate each and every hole properly. કેમ એવું? કારણ કે waterની surface આમ બંધ થાય. What does surface tension do? It does not allow surface to break. And water ने आने अंदर जो है तो the surface should break. I hope you understood what I said. So if you add detergent or soap, then it will decrease surface tension. Then the water will be able to. Another reason why we should wash with hot water is this. ये लग लो ऊपर लग दो. Surface tension decreases with increase in temperature. આવું લખાયું. P for temperature, S for surface tension. If temperature will increase, surface tension will decrease. Simple reason, intermolecular attraction. Okay. Same as viscosity is reason. Done? Everyone noted this? Yes. That's why washing with hot water is better, right? And adding detergent is also better. એને surfactant કહેવાય. એવું સાંભળ્યું છે? Soap and detergent are called surfactants. એની ઉપરથી જે ઓલા લોકોએ surf એવું નામ આપ્યું, short, right? Never mind. Questions we are going to solve next time. Assignment લઈને આવજો. થોડું બધું બાકી છે ને એમાં, બધું પૂરું કરશો ને? Doubt with what? Doubt with chemistry? The chemistry book લઈને આવજો. Okay. Turn the